And good morning, everybody. It is December 4th. So this whole chapter that we're working on is called rational functions. And what a fancy word for something that means fraction. The word rational, rational numbers are fraction, and functions, graphs. So it's graphs that are functions. Okay, so we looked at yesterday in first period, and in second period we looked at this, where this number was 24. We looked at all the multiples. Well, this is the basic, we call the parent function. This particular function right here is our parent function, okay? Y equals 1 over x. So I can look at this on my calculator even, but it's easier just to look at it just by graphing. So go ahead and I'm going to put 1 divided by x and change my window a little bit, make it small, because it is a small graph. Because you're looking for all the multiples of 1, right? You know, and go -5 to 5. Let me graph it, okay? So, oh, doggone it. Hold on. Let's go back. Y equals, go to my window, -5, oh, to 5. I get it. Okay, there's my mistake. Let's graph that. Okay, here it is. So that's my parent function, and I'm going to go ahead and I'm going to put that on my graph, okay? So it looks like this. This is our parent function, and this is the graph we're going to translate today. So if I look at this parent function, yeah, that's right. Then here's what I know, okay? I'm going to have at 1, because the multiples are 1, 1/2 and 2, 2 and 1/2, and it looks like this. The same thing, -1 times -1. -2 times -1/2, -1/2 times 2, and the other graph looks like this, okay? Now, we have horizontal asymptotes and a vertical asymptote. So my horizontal asymptote is at y equals 0, and my vertical asymptote is at x equals 0, okay? Now, what we want to do is take these graphs and move them. But before we do anything, let's take a look at the asymptotes. Now, here's something you cannot do. You cannot divide by 0. In fact, if you look at the graph itself, x does not equal 0. Heads off to infinity in both directions, positive, negative, infinity. Cannot divide by 0. So I like to do this little trick. It's kind of fun. So watch. Alexa, what is 0 divided by 0? Now listen.
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And your friends are sad because they don't exist. Oh wow, this escalated quickly.
So that could be a real bummer. I mean, you can't divide by 0 because you'd have 0 cookies, and you'd be dividing by 0 friends, which that's impossible. So either way, the idea is you can't divide by 0. So right here at 0, we're divided by 0, and it cannot equal 0. So you can't divide by 0, you get an asymptote. X cannot be 0, 1 divided by 0. In fact, check it out one more time. What is 1 divided by 0? You can't do it, right? In fact, you can't divide by 0 by any number. So you get an asymptote where you divide by 0, and then you get a horizontal asymptote because it cannot equal 0. Okay, so now let's take our parent function and let's make a translation out of it, okay? So what we have is our top number, is our multiples. That's, we saw that as 24. We did an example of that in class, well, in Zoom. This number is going to be our horizontal shift of our graph. And this number is going to be our vertical shift of our graph. Remember, if it's on the inside, so think of this as being on the inside, it's going to be opposite direction horizontally, and then this is just going to shift it up and down. So let's take a look at example 2. Now granted, example 2, if you have Desmos or if you have a nice calculator, you can do it. But I can do it faster without my calculator. But I'm going to show it anyway, okay? Y equals, clear that, I'm going to go 4 divided by parentheses, x, subtract 2, and then plus 3. Okay, if I graph this, it looks like this. Well, I need to take a look at my window, make my window a little bit bigger. I can do that. I can do that, and I get it there, okay? But it's kind of a pain. There are 2 asymptotes. The asymptotes are invisible, so you got an asymptote here and you got an asymptote here. But again, the asymptotes are invisible. You can't see them. Okay? So then, what happens is we can graph this. So what we're going to do is take our parent function right here, and we're going to move it. We're going to move it to 2. Remember, it's the opposite. It's the opposite. And 3. So, I'm going to take my parent function, go like this, and let's see how this works. So the way to move it is to move the asymptotes. So my asymptotes are going to move to positive 2, positive 3. So positive 2 and a positive 3. Okay, I did my translation. Now, think about this. If x were 2, okay, we're going to hold in. If x, think about this. If x were equal to 2, you put 2 here. 2 minus 2 is 0. Bad news. X cannot be 2. Put 2 here, 2 minus 2 is 0. Can't be, divided by 0, you're in trouble. So, that's why we have an asymptote at 2, a vertical asymptote. So now our graph. Let's see, multiples of 4, but from here, that's where my origin is moved. 2 times 2, 4 times 1, 1 times 4. Okay, my graph looks like this. And then on the other side, 2 times 2, 4, negative 2 times negative 2, negative 4, and 1, and 1, and 4. And here is my graph. Okay, now that actually should look like what I have on my calculator, but it's much nicer. We can do it by hand, okay? So, what do we know? We cannot divide by 0. So let's talk about domain. Domain's the x values. Domain is the x values, right? So when I think about the domain, it can be everything. Look how it goes forever this way, but it does not equal 2. So my domain is going to be x equals all real numbers except, that's my except all real numbers. So it goes forever this way, forever that way, except x cannot equal 2. So it's everything but 2. Now the range, if I take a look, the range goes forever up, forever down. So I'm going to say the range is y equals all real numbers except y does not equal the value of 3. Okay? Alright, we're going to keep working on this. Remember, you cannot divide by 0. That's the big key right there, okay? So I flip my paper over and I look at this example, okay? So I've got example 3. I've got a 2x plus 8 over an x minus 2. Okay, before I do a whole lot, I do know that x cannot equal 2, right? Because 2 in here, 2 minus 2 is 0. Can't happen. So for what I do know about this graph is I'm going to have an asymptote at 2, a vertical asymptote. Before I even graph it, I do know this. A vertical asymptote at 2. Now, it's not in this really nice form. I want to put it in this form here, in the standard form of y equals some number a over x minus h plus k. Alright, well, what I'm going to do is try and do a little bit of long divisions on this. So let me get another piece of paper out here that I can do long division on. So I'm going to try and divide it out to change its form. Okay, so if I take x minus 2 into 2x plus 8, let's do long division. Okay, so I'm just going to divide it. So x goes into 2x 2 times, right? Then I multiply. This times this, this times this, gives me a 2x minus 4, right? And then I subtract, don't forget to subtract, double negative, and I get a 12. Okay, so then what do I have? I have a y equals, long division, 2, right, 2, and then I get plus my 12 over my x minus 2. Okay, I'm going to put that down. So this has the same form as this. So let's rewrite this. So we have really a y equals, same graph, but just in a different form. We'll go 12 over my x minus 2 plus 2, okay? Right, so now let's take this. I'm going to graph it down here. Graph it down here. Sorry, that bled through. You know, I need a copy machine. I'm not at home. Or I'm not at school. I'm at home. So, you know, things are not working great, but I'll be back at school next week. Okay, let's see what I got. So, I can do this. I know I have an asymptote at 2, right? I know that my other asymptote is also at 2. My horizontal asymptote is also at 2. I'm going to take the multiples of 12, right, and do my graph. So from my origin, or my shifted graph, I'm going to multiply 12. So let's see, 1, 2, 3, 1, 2, 3, 4. How about 1, 2, 3, 4, 1, 2, 3, and of course a 2 and a 6, 2, 3, 4, 5, 6, and a 6, 1, 2, 3, 4, 5, 6, and a 2, and it looks something like this. And I do the same thing here. I can go multiples of 12, I can go 3, and a 4, and a 4, and a 3, 6, 2, 4, 6, and a 2, and a 2, and a 6, 2, 4, 6, right? And there's my graph. And again, I could probably put this on my calculator, but that's not too bad. Okay, now, here's my graph. So my asymptotes are at y equals, so my horizontal asymptote, y equals 2, and my vertical asymptote is at x equals 2. Right? Domain. Well, it's forever, except for it can't be 2, right? Because if it's 2, you divide by 0, that's bad news. So domain goes forever in both directions. X equals all real numbers, definitely, except it does not equal 2. Except x cannot equal 2. And the range goes up forever, goes down forever, except it doesn't have a height of 2. So we'll say y equals all real numbers, except y cannot equal 2. Okay, we'll look at doing this a little bit more when we get into our Zoom. It's a little bit hard, but I know we can do it. Okay, so that's all I have today. We'll talk about this again on Zoom, especially a problem like this.